be the tuner respond this time. I don't know. Someone might actually take over from me later, but as stands like this, I'll be the one that will be handling this program, this training for now. All right. So can you see my screen? Let me show that we have everybody. Can you see my screen?
Not yet. No.
Oh, sorry, I'm not sharing it yet. All right, how about now?
Yes.
Okay. So, so we start from talking about understanding analytics. I believe everybody on this call has done analytics in one way or the other. Maybe it might be maybe just in your final year you did some, but maybe not, maybe not, because some people they will just get their project and you just need their analytics done to someone to just let me to do it, just let me to do it. I will just pay, but then it's actually maybe do something. But as we get on to in this course, we're going to understand some concepts of analytics. I hope my voice is clear enough.
Yes, you're clear.
So in this session, we'll be explaining the need for analysis and how it is different from reporting. Explain the features of basic and advanced analytics. Explain the skills needed to be an analyst. So let's get started. So data is the basic element for any analysis because even without data, you can't start doing analysis because you don't have anything to work with. So first of all, data is very essential, which is the basic concept or basic element you need for any analysis. So we are going to focus on characteristics and need for data analysis. So with the help of modern technologies, industry experts implement advanced analytics to the available data we have. This way, we have big data, we have enormous data coming in seconds, minutes, hours, or even on a daily basis. So this data needs to be analyzed, and we need advanced technologies to work with this data to get useful insight from it. So based on this, experts are able to make accurate and more profitable business decisions. So talking about analysis versus reporting. So reporting provides data while analysis provides answer. So what reporting is just aggregating data in a more readable format whereby you can communicate to your user that okay, let's say I have a data somewhere, the sales data, I should be able to say okay, on average I make, let's say, 150,000 daily, or on the average I have 20 customers to visit this store daily. So that is basically important, just be able to aggregate your data and tell something out of it. So what analysis is providing answer because you'll be able to now do that. Okay, why do I have just 20 customers on the average patronizing on the daily basis, or why is that in particular maybe on a Sunday I have less customers patronize me, or maybe on a particular day of the month there's always a dip in the rate of customer that patronize me. So analysis provides answers. What provides data. So what provides what is asked for, by analysis provides what is needed. So reporting is just like, okay, I need to just everything and okay, get me the average salary of employees in the marketing department. All I just need to go into the database and just fetch the data and aggregate it based on a department level and complicate the information. But analysis provides what is needed, and so that's having to go a bit further into what the report is saying and having to tell, okay, why is this thing happening and what can we do to stop it from happening. So reporting is typically standardized. It's just have to understand your basic SQL review and aggregating function and all of that. So it's just follows a particular routine. So, but analysis is typically customized because there is no one way of having to get insight from data. So another person can see this data from one angle, and while another person entirely can see it from another angle entirely. Also, reporting does not involve the person, while analysis involves the person leading the process. So that's why you always have a team leading analytic project. But if it's just having to just aggregate and report data, it doesn't necessarily have to have someone involved. You can just automate your procedures and it's just generate the file, just send it and so that is just reporting. It can be automated. So reporting is fairly inflexible while analysis is extremely flexible. So that's basically what we talk about reporting and analysis. So reporting leads to analysis, and while analysis can also, at the other way around, lead to reporting. So for example, I might have a data, and I just say, okay, can you just help me generate, give me a summary of what I have in my database to say. I own a supermarket, a superstore. Then someone just gets my database and aggregate my data and says that okay, on the average I have this number of customers partnering my store, but probably on a particular day of the month, there's always a dip in the number of customers that patronize my store. Let's say on average I have 50 customers, then maybe on every 15th of the month I have like maybe just 20 customers to patronize this customer. But I've not noticed that. We're able to notice that through that report. So you might want to be interested in what actually happens on the 15th, whereby I have a dip in customer that patronizes me. Then in that case, you have a report that is leading to analysis. Then you can go and do an analysis to try to put the reason why I usually have a dip in the rate of customer that patronizes me for a particular day. Then whenever whatever I get as a result, then I come back to it and say, this is the reason why you always have a dip in customers that patronizes in this day. Maybe it's because of a particular maybe festive period or one event usually occurring 15th of the month in your locale. That's why you usually have a dip in your customer. Then at that particular point, you already know what happens now. So moving on, that analysis that I've already generated will just become a standard report. So in that case, the analysis is you already derived and become a report. So it goes either way. So reporting can lead to analysis, while analysis can also lead to reporting. So moving forward. So talking about the analytics process, we have like 6 of them, which is having the business understanding of the problem you're trying to solve, the data understanding. After you understand the business problem, so you have to understand the data you are trying to use to solve the problem. So after you get the data, you need to understand the data. So you need to collect the initial data, describe data, also explore and also verify data quality. See, is this this data I really want? Are they actually? So that when you talk about veracity of data, it's very essential also. So after understanding the data, then you can move forward to doing a data preparation. In this case, you do your data cleaning and all of that, and that's actually like over 70% of your time. You spend time cleaning your data, select your data, clean the data, construct, integrate data, and format data. Then after you've done all of that, then you can now model your data. So if you want to do maybe maybe you're interested in doing a classification model or regression model. Select modeling technique, generates test design, you have a train and test it. Then you build your model. So after you build your model, access it or validate your result and validate your model, check your model performance and all of that. Then data version like evaluate your results about that. Then review the process to look at. Moving forward to determine the next step, which is like deployment of the model. Then you deploy the model. So let's say you use the model to check whether a particular customer is going to default a loan or not. So after you've done that, you've evaluated it and it's working fine. So for new customer that has going to apply to a particular maybe loan, then you can use that model to test and see whether that particular person is going to default a loan or not. So also you have to uh, keep on monitoring and maintaining the model and also produce a final report at the end of the stuff. Okay, this is how the model is actually improving and working. And I did not want to also go into your project. So that's just the routine of the analytics process. So moving on to the next slide, we have basic versus advanced analytics. So in basic analytics, so basic analytics is used to explore data using just simple visuals of simple statistics like histogram, your bar chart, and so that. So basic analytics process investigates what happened. So with my bar chart or a simple bar chart of my histogram, you can say, okay, I have on the average 20 customers that patronize me in a day. Okay, when it happened, okay, I can see that. So as per the example I gave, I said when you generated the report, you were able to see that on the 15th of the month, you have a dip in the rate of customers that patronize you in the day. So you can see, okay, when it happened, what was its impact? When we're talking about advanced analytics, using algorithm for complex analysis to investigate what caused it to happen and what can be done about it. So basic analytics involves slicing and dicing, that's kind of activity of data, that's reporting, simple visuals, and just basic monitoring of data. Basically, you can just take reporting of data. So, but advanced analytics involves more complex analysis, such as predictive modeling or pattern matching techniques implemented on data. So when you go into digging deep into the data to find some patterns and generating some useful insight to make business decisions. All right, I hope I'm communicating. Hello, sorry, I'm feeling like I'm the only one on this call.
No, Emmanuel, I just joined in, so I'm with you.
Oh, okay. So
the only one.
so yeah, talking about the introduction to data mining. So data mining is the technique of exploring, analyzing, that's exploring, doing your exploratory data analysis, analyzing and detecting patterns in large amounts of data. So you have a pool of data, you are able to go into that data and have a feel of it and see what's actually happening within the data and detect patterns in that data. So it is used in sectors like retail, financial sector, communication, like telecom, marketing, organization. So application of data management, what are the applications of data management? It determines relationship among, say, internal factors like price, product positioning, staff skills. So pricing, okay, uh what kind of price can we give to that product to like price optimization and that kind of stuff. Then we're talking about external factors like economic indicators, competition that's having to consider other competitive products in terms of product management, and also customer demographics, like trying to understand the customer. It can be through social media analytics, like your sentiment analytics. What are people actually talking about your product? You can use that to derive useful insights on how to best develop your product, when talking about product design and
Hello, sir.
product.
So we have a lot of background noise there, and it's not making us hear you clearly.
It's it's my isn't that deep party here? Isn't that deep party here? It's all these people that just, and I'm using a desktop. I can't. It's not something that I'm move around. What can we do? So please just give me a minute.
All right.
Hi, Ayola and Kola.
Petra.
Hello. Hi.
Okay. Ayola, my first direct hi to you.
Hi.
Hi, hello.
Sorry, I'm very sorry. How about now? How's the noise? I don't know. The noise is just all over the.
The noise is
Can you
like
hear
an
me?
echo. It's like as if as you're talking, I'm hearing a loudspeaker that's like echoing something.
Like you are speaking like Ojopangogo, you know Ojopangogo.
Are you there?
I'm here.
So, can you hear me clearly? But can you guys hear me clearly? Probably just have to, like,
I can hear
you
you,
have to,
although it seems like it's still an echo.
uh, let me try and use probably, let me connect my headset so that's going to be better. Hello, can you guys hear me? Can you hear me?
Yes, it's better.
Okay, it's better now, right? Okay, fantastic.
Yes.
Okay, fantastic. Okay, so okay, moving on to the next slide. Hello, is it good now?
Yes.
Okay. So talking about characteristics of big data analysis, I think we already talked about the three B's, which is velocity, volume, and variety. So big data analysis has many characteristics. It can be programmatic. That is, there is no one way of actually doing that. You can use any kind of program to as long as you are generating the same result or generating useful insights, you can use R, use MapReduce. So there's no one way of trying to make sense out of data. So it can be data driven. It takes a lot of data. You don't have to maybe have to take a sample out of the data. You can take the whole data set and work on it and use that to drive business decision. So it can also use a lot of attributes. A lot of columns. You can consider all the columns having up to maybe take some significant uh, columns that actually maybe that actually is correlates with maybe the dependent variable. You can consider everything instead of having to pick some attributes and leave others. So it can be iterative. So it can also be iterative. So okay, what are the skills required to be an analyst? So all the data collected and the models created are only if the organization lacks data analyst. And that's why we are here. So big data analysis requires both skill and knowledge. So to be successful analyst, be a successful analyst, your profession now requires expertise in various analytical tools such as R, SAS, or I'm basically talking about R in this course. So and is able to take decisions which are both statistically significant and important to the business. So it's not just saying the word by mouth. You have to uh, prove it that it's being backed up by data, and so that's going to give you a lot of sense that you actually know what to say, so that you can use this insight to drive business decision. So talking about the convergence of IT and analytics, so let's see how these people actually converge. So analytics teams are asked to heavily utilize system resources, while the IT teams are told to tightly manage resources. So we have a kind of contradictory factor here. So analytics teams are to create tables and use a lot of space, while IT teams limits table creation and space usage. So the IT guys are the ones like, okay, they make sure that everything works well. Everybody has the resources to make sure things are actually going very well. But the analytics guys are the ones that we just need to get insights. We need to get this data and try and run some kind of process or procedures and get useful insights from this data. So they use a lot of resources. Whereby it gets, so I could remember back then on site when you go and the process is running, and if those IT guys just notice that you are running the process and it's actually limiting some performance of guys in the organization, you'll just cut off your network and you just kill your process. So probably your process is already like 99% complete, you just 1%, you just kill it. So IT then and the analytics team have to work together for the analytics team to get prepared out of the data. So the analytics guys are to run complex and ad hoc queries, while IT teams minimize use of complex and ad hoc queries, as I've already used as a case study where we work on site. So IT guys, the analytics guys are told to go outside the box and forecast future patterns, but IT guys have to keep users within the box. So you just have to use what you are meant to. So if we are to just use like maybe 2 big gram to do a job, is that 2 big gram enough? You don't go outside it. By the time you are using something out of that 2 big gram, you are going to cut off on the network. So the analytics team that will experiment with new approaches and build new strategies, while IT teams are stick to approved approaches. So it's like if the board is saying you should be using it. If you are to be using Power BI, you use Power BI. If you are to be using SPL, Oracle SPL, you use SPL. But probably me, maybe Oracle SQL is not really flexible. Me, I want to use, I want to run SQL server. Then you are going to be having issue and stuff like that. So the analysis guys are to work with limited rules and restriction. So, but the IT teams enforces rules and restrictions. So in this case scenario, the analytics guys and IT teams have to have a good relationship for them to make sense out of the big data available by an organization to drive business decision. Okay, yeah, I think that takes us to the end of this session. Here are the summary of what we have talked about today. So I think I'll just talk about some basic things. So for big data analysis must be decision oriented, so and action oriented. So decision oriented analysis is the ones the kind of analysis you make to make businesses you get decide on what to do. There are some analysis that requires you to take action, to take action immediately, like, oh, something is really happening, then you want to take action immediately. So, but there's ones that during that analysis you used to make to business decision, but the ones that actually needed like urgent action, that's what we call the action oriented analysis, which requires urgent attention. See, let's say uh, you realize you're able to see that, okay, maybe you are able to build a model to tell whether a customer is going to churn or not. So if that model has already alerted you that this particular customer is going to churn, then uh, you start sending campaigns to that person so that the person will use the particular service. So basically, talking about the steps included in the analytics process, the basic analytics, uh, the basic, we talked about basic analytics and advanced analytics, and characterizing of big data analytics, and I think that's all. That's all. So before we go to the next session, do we have any question before we go to the next session? And I hope my voice is clear. Hello, are we together?
Yes, we are.
Yes. Yeah.
All right. Okay. Okay. So the next presentation we have is talking about analytic tools. So here we are going to explain the features and importance of our features and importance of IPMS spaces to SaaS, and compares various tools, like the three of them together. So analytical tools are used to prepare data for analysis, execute algorithms, access the results of the analysis. So analytical tools also automate analytical tasks for professionals. So if you are so good with that tool, you can automate some analytical process. So with the help of analytical tools, professionals get more time to focus on analysis, because we have some steps automated, and just have to take your time to face what really matters. So talking about the evolution of analytical tools, in the late 1980s, user-friendly tools were not available. So jobs are mainly done using the JC or job control language, while in the late 1990s, coding interface migrated to new platforms where we have rudimentary graphics were implemented. So in this scenario, you have just like they use like pipe, this pipe and dashes to build charts and all of that, and you have to write. You have to be knee deep in writing code to get started. But post 2000, all commercially available analytics add interfaces. So you have great sophisticated GUIs whereby you don't even need to write code. You don't have to be native in coding before you can generate insight from analysis. So all you just need is just drag and drop. Just all you just need is just drag and drop. But then you have to have the basic understanding of what your drag and drop is actually doing. If you don't have those basic fundamentals, as it's easy to drag and drop, it's very easy to just do the wrong thing. Like, let me just play that way. So just talking about the categories of analytical tools. So we have the statistical data analysis tools and data visualization tools like Power BI and Tableau and the rest of that. So all commercial analytical tools come with user interfaces. So the development of tools started from tools with no interfaces to tools with sophisticated interfaces. So with the help of above tools, the focus has shifted from coding to just utilities. So talking about visualization tools, we have great visualization tools like Power BI and Tableau, whereby most of the things just do is just drag and drop, like click stuff. You don't basically write code unless maybe you want to create some custom programs and maybe calculated measures, then just write some basic code. So you don't have to write code per se. So going to the next slide, we so we're going to talk about some popular analytical tools starting from R to the R project, which is initially developed by the Robert Gentleman and Rose Iyaka, which actually leads to the name called R, which actually originated from the S, which is the early language for statistical analysis. So R is an open source statistical computing package, and it's used by a large number of analytical tools. So it's maybe greatly used in the educational research and educational sector. So features of R is object oriented. It can be linked with common programming platforms like C++, Java, which makes it possible to embed R within application. I think that's the beautiful aspect of how you can input R script into any platform, like almost any platform. So most commercial analytical tools have enabled R to be executed within their toolset. That's interesting thing about our tool. Say R is majorly used in academic and research environment, as I already said earlier. So what are the limitations of R? It's talking about scalability. So the base R software runs in memory as opposed to running the case file. So the reason is that if you want to do analysis in R, you have your data have to be on your local system. So it runs based on available memory. So the data that you have to run it has to be equivalent to the available memory you have on the local PC. So R handles data set the size of the memory available on the machine. And most facilities support large memories. Thus, for large organization, R turns out to be an unrealistic solution to gain big data. And programming R is also a fairly intensive process. So R interfaces are less mature than interfaces for other commercial tools. Yeah, I quite agree with that. But there are some great guys actually doing great things with R. They prefer R, they choose R over any other programming tool. But it's just what it is. So moving forward to talking about SPSS. So the SPSS analytical tool was first introduced in 1968, where the name also changed to IBM SPSS after the SPSS recently took over the tool and which is by the IBM group. It has a user-friendly graphical user interface. So I think back then most of projects are really built on using the SPSS package, where you just import your data it has a really nice interface where you can perform analysis of the data. So what are the features? So SPSS commands are executed line by line. Also, it has also a code editor where you can write code, but then it generates code for all the analytics process you do at the back end. You might not use, but there's a way you can see the code editor window for the SPSS back end. So the executed syntax can be stored with their execution time. So it can also read and write from SI files, databases, and tables of other statistical software. Also provides data management functions such as sorting, aggregation of data, transport of data, merging data into different kinds of trends. So that's SPS. I think the next slide should also, let's go to the next slide. Is that all about? I think that's all about this slide. So yeah, I think there's something missing. Let me check. Oh, that's all. I think there's something missing somewhere. So here, continue about talking about statistical tool. Yeah, SAS. So SAS, which is our statistical analysis system, was founded in 1976 in the IBM framework to handle large volumes of data. So its capacity to handle data increased with the implementation of parallel architecture. So it's an information delivery system that is used to represent a modular, integrated, and hardware independent computing package. So it works well with a very large amount of data compared to like So features of R can run statistics, data, and text mining because it works with a huge large amount of data, data visualization, forecasting, and optimization. So it's a lot of stuff you can do to SAS statistical package, not statistical to be say. So SAS is designed to deliver universal data access. Like you can access data from anywhere, provide a good user interface. So it also take the advantage of computer hardware platform also. Can you hear any background noise at the end? Let me just be sure. Because the noise has been okay. So SAS is mostly used by social behavioral scientists for various types of functions, spreadsheet analysis, and all of that. So SAS products can be sold separately or in sets. So SAS has different kind of solutions whereby you can just like there's a part of maybe SAS product that can be used to perform some specific tasks. So they have specialized solutions together, and you can also have everything in house depending on. So it's not kind of like so SaaS solutions offer a number of techniques and processes for guided decision making. So, but ultimately we be doing our discussing. So here we'll be making comparison to the three uh, tools we talked about today as SPSS and SAS. So talking about the user interface, I think we already said how doesn't really have a nice user interface per se. And so it's a least visually interactive analytical tool. The tools are available for providing GUI support for programming we have. So you can write your codes in different editors, say Notepad, Word, and all of that, and actually save it as .r file and send it into R. It's actually fun. But here it supports a moderately interactive GUI, but SAS has the most interactive GUI. Also, in decision making, since lacks application of three algorithms, I think the one we have in R is just CAT, which is like the classification and regression tree. So it provides a lesser user friendly solution, okay, and with SPSS provides the best and economical statistical solution. And on SaaS, it says it requires the use of external data mining suites for better decision tree approach. Okay. Um, so
Hi,
talking about
Emmanuel.
data,
Hi, please,
yeah,
what's GUI?
graphical user interface.
Graphical user interface.
Yeah. Do you understand? Yes, that's right.
Yeah, I get now.
Okay. So, in terms of data management, how supports core data management techniques as data has to be loaded into the memory. I think you already talked about that. So IBM provides moderately performing data management, but SaaS apps uh, outperforms them all in this regard, even mostly in every regard. But as easily, in terms of documentation, as easily available, elaborate documentation, but it's an open source, so it has also have programs like it's how programs where you can get help on maybe you're finding difficulty with particular function in the open source programs where you can just get help from them. But IBM spaces, due to its limited use, spaces lacks elaborate documentation of its functions and packages. Mostly, it's being used in the education sector and in the research work. So they don't really, you can't really do much on spaces compared to like how it's flexified. So they have large community whereby you can just easily get help depending on what you're doing. So what SaaS has a comprehensive technical documentation of more than 8,000 pages. But so you can mostly all these tools have documentation. It depends on their popularity also matters. So depending on how people actually use this tool. So you can have people write stuff about it. If you just do research and just try to get into something. You have seen someone that have done that before. You just see that thing popped up on Google and that thing just didn't solve the issue. But compared to some tools where you hardly see people are not really using it. So if you have issue with that kind of tool, to get help with it is quite okay. I think we have illustrated this slide. So here, talking about the summary of what we have done today. So yeah, yeah. So there's nothing much in this slide. Nothing much in this slide. Let me let me go to this slide. So as an open source analytic tool with the following capabilities, more object oriented than other tools, can be linked with common programming platforms C++, Java, and can be enabled to work with other commercial tools because most tools also are embedded in their environment. It's extensible and
Emmanuel, we lost your voice.
Hello, Emmanuel.
I think we're done with the class. Hi, Kola.
Done.
I think so, because I'm not
Sorry,
seeing. Okay.
sorry. Is this clear? I used to be that God name famous.
We're just thinking with the class.
Is that?
We're just saying that, talking to ourselves, that were you done with the class?
No. So okay. So basically, that's just it about this session. Interestingly, we are going to move into like all the practical part of it. So here we are going to be exploring R. So let's see how far we can go. So here we are going to be exploring R. So we all have the virtual app all installed on our PC, right?
Yes, I do.
Color Alpha.
Yes, what's that?
Okay. Basically everybody have it, but I don't know. Okay, let's go. Since if you have House Studio installed locally, well then it's fine. Let's just use virtual lab. So let's just use virtual lab.
So where are we feeding data from? Is it the virtual lab or
And the data is on the virtual lab. For the practice, the data is in the virtual lab. For me, I already expected the data. I have it on my local PC, so I already expected the data. I might not necessarily, if I want to use my maybe I want to work with I might not necessarily have to
okay.
virtual lab unless maybe I want to work on the ecosystem. So here we are going to distinguish between various editors like RGUI and RStudio and their components. So also develop scripts for execution in R, execute develop scripts in R. So let's see how it's goes. So here we talked about R. So let's go right again. So the programming language used for performing statistical operations. It's an open source maintained by the R project, that's R code development team. It is a team of volunteer developers from across the group. It can be accessible through this website, www.r-protect.org. You can download R from there. So if you want to use R Studio, you have to download R and install R on R. Then you go along to download R Studio. So R Studio gives you a more robust environment to work with R rather than R itself. So let me show you how. So if I have this is let me just make it. So if I just this is just this. If I should open this guy and this now, you're going to have something like just like a Python IDE. So you're going to have something like this. So basically you're going to have your console like this. So your console, this is your console, you can type anything. It's not coming up here. So this is where you can type your operations. So you can do 1 plus 1. Enter, I have my result, following result as 2 here. But if I don't want to use this, I don't want to write my code directly in this editor, I can use the script. So I can say new script. Then this is like my editor where I can write my code and say okay, 1 plus 1. I can say print 1 plus 1. But whenever I'm done here, I can just run or whatever I need to run in. I just maybe I'm done and just copy and paste in the console and just run it. I can just and paste my code and just have it here. But it's not really flexible in this kind of format. So that's why you have the House Studio, which is more robust to use compared to this House UI. So let me just do this for now. So, so what are the major features of R? It has an effective data handling and storage facilities, and it supports a large pool of operators for performing operations on arrays and matrices. It has facilities to print the report for the analysis performance in the form of graphs, either on screen or on hard copy. You can see it on screen, and you can also export it out as PDF. That's, you can do that without PDF. I don't know, maybe you can use that the RGUI. So working with scripts. So R is utilized as a statistical processing environment for solving problems. So also it provides freedom of selecting to interact with the native console. So I can type my script in maybe Notepad, Word, and just save that .r and just run it on R itself. So that's basically fine. So the R developed R script can be executed in the selected editor. So we have two prominent editors like the RGUI and the R Studio. So I just showed you guys the RGUI. Then we have the R Studio, which is the more environment that you are going to be using basically. So this RGUI is not it's out of it. So let's move on this slide. So someone is sorry, I have no. Sorry. So talking about the RGUI, it is a standard GUI provided on downloading and installing app, which I just finished showing you guys. So the console window in R is the place where instructions, scripts, and general app operations are performed. That's where I wrote my 1+1, and I ran it. So that place is your console window. So the RGUI can be accessed using the menu shortcut created during the installation process. That's where the shortcut was created on desktop. So that's where I went to just click and just open it. So the app prompts a greater than symbol. So if you see when I open the RGUI, you see greater than symbol. So after that greater than symbol is where you can now type your format. So to quit, you can just type Q, then open and close brackets to quit the user interface. So let me do that again. So let me open this. I have this guy. So this is where you can write the command. I can see the greater than sign. So if I do my perform operations, I can say print 2 plus 3, and I have my results. I didn't. You can see that I understood that I've not finished writing my statement because I have a bracket. I've not enclosed into another bracket. So it gives me a plus sign that okay, there's still something I'm typing and I've not finished typing. It's just trying to tell me the way that guy you have not finished typing. So you do I finish that with 15 the time. So I'll just put the close bracket, then I'll just enter, then paste the result for me as 5. So probably I'm done with what I'm doing here. Then I just use Q, then open bracket and close bracket, and enter. And you can see it's giving me a prompt that they want to save my workspace image. I'm not interested. Just click on no. Then that's just it. So moving forward. Why my network lagging? So I don't know this network. Let me change my network. No, 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 no. Okay, it's fine. So we have House Studio is a code editor and development environment with the following features: code highlighting, automatic bracket matching, code completion, easy access to RF, easy exploration of variables and values. So let's see how this works out. So let me close this. I'm not using this application. Let me just close. Okay, I have my House Studio open. This is House Studio. Can you see? This is House Studio. So I was working on House Studio before. So I have it open. So this is how it's listed. You have four windows: 1, 2, 3, 4. We are going to talk about this more when as we progress in the class. So this is my editor where I can do anything I want to do. It's just open. Where I can write all the codes I intend to write. So here is where I can type anything I intend to type. Then this my workspace where I can have access to file, files, packages, stuff, and so going to the first thing we have here. What's happening to me? So he said code highlighting. So what do you mean by that? Code highlighting. So write this one like this. Sorry. So let me go back to my script. So let's say, for example, I want to sample script. So let me continue. So I want to do something. So print. So I did print hello DASCA. And I have another statement here. Say print I'm good. I want to do this. I am good. So if I want to run this whole command, this line 73 and line 74, I can just highlight this guy. Then I can just press Control Enter and run it, as you can see here. So this second one didn't run because I used capital P. So it's telling me it doesn't understand. So I can just highlight and run. So you can see that this first one ran, I have a DASCA. And this second one didn't run because this one is capital P. So it doesn't understand the print function I'm trying to call. So that's about code highlighting. Then automatic bracket matching. So look at this now. So this is what it's talking about here. If I say print, now if I press shift and the first bracket, it just creates the second one for me automatically. I don't need to type close bracket. So if I use this bracket, you can see it just creates the close bracket for me. So I don't need to have to type the close bracket again. So it does the second one is talking about here. Code completion. So what do I mean by code completion? So if I want to type print now, so if you see, if I type PR, it will just, or let me say I, you can see it gave me some options already. So if I want to print, I don't need to type that, just come down here, then enter, and just give me this. So that's about code completion. Easy access to RF. Easy access to RF. So maybe I need help about the print function. I don't need to go to Google. I don't necessarily need to go to Google, though you might want to go to Google, but I don't necessarily have to go to Google. I can just say, okay, I can use the question mark and say print and put print in front of it. If I run this using Control Enter, then this guy just goes to the help window here and it gives you what you can use with the print function. So if you have this, so you have all this documentation, I can go through from here instead of having to go through web. So this is just like a web interface to tell you to just gives you the whole overview of the print function. Another way you can use this is, I think you should be able to use it, the help function. So help, then you can put what you need help with, say print. Then you run this guy. Then it's still loading. Then it gives you this. So it's actually interesting. Also talking about easy exploration of variables and values. So here what it means is that I can see all of the variables and values I've created here. Can you see them here? 3 feet, training set. So all of these values I've created, all of these variables I've created, I can have access to them. So I can have access to them using this environment variable. So that is one. I think let me allow someone. All right, thank you very much. So that's about easy exploration of variables and values. So as today is available free of charge for Linux, Windows, and Mac, as you can see that I have it on my videos. So it can also be accessed by clicking the Ask Today icon in the menu system on the desktop. So you say Ask Today has the following components: the source, console, workspace, and history. package and help. Source is where like your editor. That's the one at the top left corner, which is where you have these guys. The top left corner, that is the first quarter. Then you have the console, which is this window, this one at the left bottom here, where you have where your code is, your command is going to be running. And you have this where you have your global environment, is where you call your workspace and history, where you can see what you have done so far, the variables you have created. And you have this one at the right bottom here, which is your file plot package and help, where you can see the available package. You can browse through your files. You can see plots. You can see plots. You can see available packages that you have already installed and all the help and the viewer window. So that's basically it. Then so doing simple math in R. So here talking about this math in R. So now let's create a script to print every word in R. So to create script in R, perform the following steps. So I just go to the this one. You can see that it just prints any word from the console. Then what follows by the time you click on enter is the output that you have here. So this one is saying that the first value you have is hello world. And I think we have already illustrated that using this guide. So print hello DASCA. Then what you see next is print the output as it is here. So if you see here, you are going to see one. One here means like you just have one value. So you just have one value, one result. So if your value should continue to the next line, you're going to see. So let's take an example. So let's say I want to create a new script, say DASCA practice. So let's say let me generate a sequence of vectors 1 to 50, for example. So let me run this. So as you can see, you have one here telling you that this is the first element, then this is second, third. But I get to 28 elements. You can see that 28 was here. So this is telling that this is 28 elements and all of that. So this is 28 values. So this is just like the numbering of the results you have in the console here. All right. So now you can perform arithmetic operation. This also follows the rule of basically PEMDAS. So let's put it as PEMDAS. So parentheses, exponent, multiplication, division, addition, and subtraction. So you can also perform complex mathematical operations, as you can see here, but it's going to follow some. So let's do an illustration. So if okay, someone is asking a question. Should we just can we open our virtual lab so that we can do this using the R environment? But basically, what I'm doing now, you can actually do it locally if you have your R studio stuff. Or if you just have your R GUI, you can just do this so that we can follow. Or should I just continue before then? Or how should we do this? So I guess, can we open our virtual lab so we can have access to R Studio on our virtual lab? Or let me just open my virtual lab so that we can follow as I'm doing it. So let me just open my virtual lab. So this one I'm using my R Studio. So I have to close a particular and you need to have here. So let me just close this. I won't have to open this and have to open virtual lab. That's it. Sorry. Let me close this guy. Okay. Maybe let me close this one. I'll be adjusting. It takes a lot of memory. Have we also opened our virtual lab like this? Okay. So have we opened our virtual lab? I'm about to open mine.
Yes, mine is opened.
Where is that guy? I'm actually taking question. So it's supposed to be a workstation. I'm like, what am I typing? All right, so okay, come here. All right, so what I love to do now is play virtual machine. Okay. Hello, Chidi. Hi, Chidi. Good evening.
Hi, I don't have the editor.
You don't have virtual lab installed on your PC, right?
I don't have that installed on my PC. I will need to install it.
Okay, but do you have Out Studio probably installed on your PC?
Oh no, I don't have R Studio on my PC.
You can quickly just go to your web browser and just download R. First of all, download R and install it. It will take time. Then after you downloaded R, then you go on and download Out Studio. It will actually take time.
Okay, download R.
Yeah, first of all, download R so you can get that on how project. You can just go on Google, just type how download. So I will click on how project. Yeah, how project.
Okay, R for Windows, right?
Yes, yes.
Okay, I'm downloading it.
Okay.
I know I won't be able to download on this PC. It's company PC.
Okay.
And so I can just see what you're doing, though. I can see what you're doing.
All right. So I'm logging to this to use HG as password. And so after you've logged in, the first thing I go to like your search button, then followed by files. Then the next thing, the third thing you'll be seeing is your Out Studio. You can just click on it. You're gonna have your Out Studio. I'm waiting. So first I'm opening your Out Studio, Ayola, Kolawole, and Mary. So I have mine open here now.
Yes, mine is open.
Okay, is Ayola still with us on this call? Let me enlarge this. Yeah, better now. Just a minute. So, can you see this very well? Like, can you see my house to play? Is it very clear to us like this?
Sorry, how did you enlarge your screen, the screen like this? Because I'm trying to enlarge mine, it's not working.
Okay, like to enlarge it like this. It's like to enlarge the house studio to enlarge the virtual lab.
To enlarge the lab.
So you can just come down here, like just come and just increase, just drag it down.
Thanks.
Or you can just come here and say, okay, you can see enter full screen mode. You can just do this. You can see like this. You can do it this way. Do you see what I click?
Yeah, I've seen it.
Then after you've done that, your R Studio might not be in full screen mode, but can you get your R Studio to be in full screen mode? Hello, are you there?
I was trying to navigate to this place. Yeah, I have it full screen.
Okay, so now, as I was saying, let's perform some basic arithmetic operations. So if I do 2 plus 4 divided by say 2 minus 3. So let's see what's going to happen here. So you can see I have a 1. So how did you perform the operation? First of all, 4 is being divided by 2. So I have a 2. Then 2 is added to 2 to have a 4. The 4 minus 3 give me 1. So division takes this before any other thing. So this is the format. You have a P. Let me just increase my P. Let me zoom it so that at least it's be more visible. So you have P. What are you doing? So you have a P, you have P, you have M, you have P, you have A. Basically, let's just take this for that. So this is parentheses, this is exponents, this is multiplication, this is division, this is addition, this is subtraction. So let's do something like this. 2 times, let's do 2 divided by 4 divided by 2 times 4, then plus 2. Let's do it plus 2. So what happened here? We have a 10. We have a 10. What actually happens? So we have 4 divided by 2, which is 2. 2 times 4, 8. 8 plus 2, 10. So you say that why didn't he do multiplication and have 8 and do 4 divided by 8 to have half, then half plus 2. So the thing is that this M and D, PEMDAS, this M and D, which is multiplication and division, they can be switched. You can have PEMDAS, can have PEMDAS. But the one that comes first is being operator first. It's just like your addition and subtraction too. So it's one that comes first. So if I do something like 2, if I do like 2 minus 3. Sorry, I'm checking the next one. Like 2 minus 3 plus 4. Because A comes first here doesn't mean that it's going to do A first, but if you do it either way, you're going to get the same result. But it's not the same division and multiplication. So when you're doing the case of division and multiplication, you have to be very sensitive to stuff like this. So you are going to actually direct it to do a particular thing first by using what the parentheses. So you have to okay, if you want it to do multiplication first, then you have to put this in parentheses using this bracket. Then the result you're going to have is going to be different from this that you have here, which is 10. So if you put parentheses, then it's going to do this first before it applies any rule according to what you have here. So if I do this now, you can see that I have 2.5 instead of 10. So parentheses actually helps in this regard. So exponents is just like doing something is past something. So let's say, for example, if I should do 3 times 2, then raised by 3. You can see what I have there is 24. So what it does first is 3 is power 3, which is 8. Then 8 times 3, 24. I think that is clear enough. Is that clear?
Yes, it is.
Okay, so let's move on, please. All right. So I think we talked about this. Now, mathematical operations in R, we have this. An operator is a symbol that is placed between two values make a calculation. So we have some of these operators. We have the plus, minus, division, multiplication, and exit. Here we have a pi, which is a constant value, which is approximately 3.142. Then we have this, which is like x is power of y. So you can write it this way, or you write it that way, using double star. Any which way you write it, it's actually fine. So you have the sqrt function, which is used to take square roots. Then you have the trigonometric function, cos, arc cos, sine, arc sine, and the likes of that. Then you have a log function, which is taking log. The log function takes two parameters, the value and the base. So this is like they say log x base n. But if you don't specify this base parameter, it's going to take the natural log. It's going to assume that you're taking the natural log if the base is not specified. All right. So going to using vectors. So a vector is the simplest type of data structure in R. So a vector is a one-dimensional array. So it's just one dimension. It's just like you have a column in a data frame or a spreadsheet kind of data. So it's just like that you have a column. I didn't say a row, you should take notes, a column. So if you have a data frame or a spreadsheet kind of data, a column is unique to the data type it takes. So a column cannot have a number and a string at the same time. So it's either a number or a string. So that's why I say it is equivalent to a column in the data frame. So a vector can only take a single data type at a time. So you can't have numbers and characters at the same time in a vector. So there are two ways in creating vectors. You can create it this way. You can use these sequence operators to generate a vector. So let's see how this works out in R Studio. So I can do this. Say if I want to get the vector 1, 2, 3, 4, 5, and just do this. If I should run this, I have this result here, as you can see on my screen. Let me write it. So another way I can generate this sequence is I can do this. 5. So you can say I have the same result. So I have the same result. So if I do something like this, let's see what's going to happen. You can see that you didn't take this 10, you just took this 2. So you can't do this. But if you want to generate a sequence based on a pattern, so maybe you want to generate 1 to 10, but you don't want to generate it in that particular order. Maybe you want to skip the next number, then you can use the sequence function to do that SEQ. And say, give me number from 1 to let's say 20, but skip the next number. To put a step, which is 2. So if I should run this, you can have 1 to whatever ending you have, but skip the next value. So it skips to goes to 3, skips 4, goes to 5, and like that. You can assign this guy to a particular variable using it as the less than a minus sign. You can use equal to sign, but most of the time you use the less than a minus sign to assign. You can say A is VEC is I'm assigning this to this guy. So if I should want this now, oh no, I'm not running that. So if I should want this now, this guy has been assigned to VEC. Automatically, you are going to see it in your work history, your environment here. You can see the vector VEC has been created here. So if I type VEC, then I'm going to have it called upon here. So as I said, you can use anyone. You can use this one. You can use this guy. But most of the time, they use this guy. It's just like the our way of assigning values to a variable object. So if you want to see the list of objects you have created so far, you can use the LX function to do that. So you have the list of functions, you have the objects you have created in this session. So I've opened this session first. The one I just created is the VEC. Where is it? It's just created here. As you can see it here. So let's say I've finished working with this VEC vector. I want to remove it from the space, then I can use the remove function and specify the variable I want, the object I want to remove, which is VEC. Then I run it. Now if I call VEC now, it's not going to see it. You can see object not found because I've removed it from the space Another way I can do that is using the RM. I can use RM. I can use RM to do that.
So this R works like Unix too. They have similar commands.
Mhm. Okay, that's interesting. Yeah, yeah. So thanks for the contribution. Yeah. So now, if I you have not, I've removed this guy, so I can't find it again in workspace. So let's assign it again. So I've assigned VEC to this guy again. Let me use RM. I think I should be able to use RM to remove VEC. So I've used RM to remove VEC again. So if I call VEC again, vector not found. So either you use remove, whether you use RM, you can just remove from the space. So as I said earlier, vector only works with one data type at a time. So let me call this guy. So I've not gotten to the place where I'm talking about indexing the vectors or trivial kind of containers you have in R. By the time we get that, we'll talk about that. So let's say I want to. So let's say I want to add another element to this guy. You know, this one are numbers 1, 2, 3, 4, 5. I want to add a string to it. So I'm going to put it in code because it's a string. So I put it in code and I put, let's say, hello. Automatically, if I should create this, automatically, it's going to convert every one of these to a string. It's not going to give you an error. So because logically, don't let me put it that way. I said vectors cannot contain two data types at the time. But since I'm putting numbers and string, in the real sense, there's no way I can convert hello to a number. But since I can convert number to a string, automatically I'll just takes that, okay, you are trying to create a string of 1 to 5 and hello. So if I should run this, it's not going to throw up an error. So if I should call VEC, everything is converted to a string, as you can see here. So it's trying to tell you that, guy, I cannot give you 1, 2, 3, 4, 5 as number and give you hello as string. So everything is going to be converted to a string. So you shouldn't mistake that anytime. So I think that's all I'll have to say for now. Maybe as we proceed, we'll talk more about vectors. So moving forward, storing and calculating values. Okay, I've already mentioned this. So x is equals to 1 to 5, y is 10. I can perform calculations with vectors. So you can see here, I created x to 1 to 5, I created y to 10, and I said x plus y. So each of these x's will be added to 10 will be added to each of these x's. So I have 10 plus 1, 11, 10 plus 2, 12, 10 plus 3, 13, 10 plus 4, 14, and 10 plus 5, 15. So it also works with data frames and matrices in that order. But I think as we proceed, we'll be talking about that. Let's look at the next slide. Is there any question before we continue? Okay, I'll take that as no question. So, yeah, storing and calculating values is still on this part. So, vectors in R can be used to perform build operations like combining text. So, the C function is like a concatenating function, like just combine these things. Like you can call it anything. So, like combine or concatenate, say collate, any English word you have to just combine something together. You can call it. So creating a variable and putting its value in R. So, and I said z is equal to x plus y. You know, I've created x before and I've created a y. So I just assigned z to the x plus y. So basically these are results. So that's just this. So now I already talked about if you want to call the values in a variable that you have stored. You know, I stored this into HW. So if I want to see what's inside HW, I just have to type HW and I'm going to see what is inside. So I think before I proceed again, there's so if I want to run a single line like this, if I want to run a single line, just this line, I'll move my cursor on this line and I just type Ctrl Enter. So another way you can do this is to highlight it, then Ctrl Enter. So highlight the part of the query you want, the code you want to run, then you run it. Then it goes from up down, the up down manner. So start from here, then here, and such. So if you want to run all the things, maybe you have written your code from line 1 to line 20. You want to run everything, then you just need to type, so Control Shift Enter. You can see everything ran to this place. So everything started here. So when I pressed it, everything started from this line 1. You can see it goes source. It's created a source function. So it's like a script. Sourcing is like you want to source. So this is a script. So I'm sourcing a script. So source this guy, then it's going to run everything from beginning to the end. So this is beginning, then to this place. All right. So moving forward. So talking back to the user. So our script can be developed to interact with the user. The readline function exists to ask questions from the user as follows. So as you can see here, you use the readline to say, okay, I'll ask you a question and you give me the answer. So I can use the basic function to say, okay, let me see what we have. So the paste function shouldn't be confused as the print function. They are not actually the same. So they work in a similar fashion, but they are not the same. So this is how it works. So I might want to write my program whereby it's like it should be able to prompt the user to put in something. So let's say I want to create a function that will calculate the CGPA of the student. So I don't know the CGPA of that student. So if the person wants to use the function, I can just run it. That function is going to prompt the user. Yeah, enter the grade you have in this particular course. Yeah, when you have entered it, ask another questions. Do you want to enter in this or stuff like that? So to be more interactive in that way, and the readline function allows you to do that. So if I say readline, then I put into readline, then I'll say I can put in to prompt. Automatically, it prompt is going to this. As you can see here, prompt is equal to this, but I don't need to type prompt is equal to this. I will just put I'll say what is your name, and I can put an icon and put a space that it differentiates your name from like what is your name. Just put a space. So if I want this, you can see inside my output window here. It's asking for my name. So it's asking what is your name. Then I'll just type it. My name is Abiodun Manuel. Then enter. So you just put it. So it's just asking for the user about the background information. So which makes it very interactive and interesting. So that's about the readline function. So also sourcing is good. So we just did that using like the illustration just gave, having to run all the codes I've written in the editor using the Control Shift Enter. That's just sourcing it. But you might have written a script and just leave it and you really want to source it. So let's say, for example, I go to first of all, let's go through this. Scripts can be developed in external editors and then imported in R for execution. So you might not even necessarily have to write it in the R coded editor. Write it in any kind of editor, just save it as .R file and just source it to the R environment and add the result. So script can be sourced in either ArcGUI or the Arc Studio itself. So it sends an individual line of code from the editor to the console. So click the line of the code and then press Ctrl R in ArcGUI to execute the instruction, or press Ctrl Enter, or click one button to execute the instruction. But here it says sending the entire script to the console. You're going to use a Ctrl Shift Enter or click the source button. So which we just did by running all what you have inside this place. So for example, probably you've written everything you need to write. Let's say I've written everything I need to write. I have it in this guy. So I just want to save this guy, save Control S, and I've saved it as testing. Testing. Automatically give save as .r. So I save this guy as testing.r. So if I want to call this guy, I can use the source function. So I'll say source, but you have to know that it has to be in your current directory. So source testing.r. So if I should run this guy now, you can see it's asking me that what is my name. It's asking me that what is my name. Then I'll just then you have an issue here because you are telling him to remove a particular object, but that object does not really exist. But basically, I don't know why he did that because I'm expecting it to run everything. So let me remove this. So basically, you just have to, maybe you are written your program step by step. You just source it and all of that. So you're going to use a print function at the end of the day so that you can see your results. You will not really see, because I'm using a gradient, that's why you can see that guy here. And this iron function requires I don't know if it's so maybe just you are written your code in a notepad and you are written it in a up-down process. So you have the last line is just the final output, just put the print function and it prints everything. So let's say for example, let me program this guy. So let's say x is equals to, so let me say 1 to 5 and y is equals to 10. So let me use and z is equals to x plus y. And I said print y, no, print z. So let me save this again. So I've saved this guy now. So let me open a new script. Let's say I want to now call that guy now. I can just say source testing.r. So as you can see now, it's printed my results finally. So all it did from top down, he didn't see it. He didn't see where I created x is equals to this, y is equals to this, z is equals to this. It's just the final result that I said print something that it just saw. So that's the essence of using sourcing and all of that. So that's just script. So you just create a script called testing.r. You just source it by using the source function to just run the command. So that's basically it. I hope you understand what I just did. Hello, are we there?
Yes.
All right. So
Yes.
okay. So navigating the workspace, I've talked about the ls function. It displays the list of variables created in the workspace, and the rm that you can use it to remove all the variables you have in the workspace. So let me go back to that list again. So let me see the list of functions I've. So these are the variables I've created in this workspace. In this current section, you can see. Oh, this is not my. I was like, this is not my VMware environment. So let me say let's command again. So these are the variables I've created and all of that. So let's say I want to remove everything. I can just say rm, and I can say I can pass this ls command into a list. Let me see how this goes. So, so list is equals to, let me start this one more. So if I should use my ls command again, you can see there is nothing inside my workspace again. I've already cleared everything. As you can see that this space is empty. There's nothing inside. So what I just did is that, okay, remove using this guy. So I just specify this. So this is just everything inside the workspace. So like everything here, apart into a list. So just remove everything. So basically that's just the command. All right. So now saving your work, saving your work. So I provide the following option for saving work. Individual variables can be removed using the using the save function. So you can save your variables individually. The entire workspace can be saved using the save.image function. Also, the out script can be saved using the appropriate save menu command in the code editor, or just do Ctrl S. So the save content can be loaded into the R workspace through the load function as follows. So using the load, so the file name I've set up rda.rda, that is data. We use the load specified file for memory to the current workspace. So I think we are able to cover this part of this session, talking about exploring. Is there any question? Like, is there any question so far as regarding what we have talked about so far?
You will share the slides with us, right?
So this that I'm using is the online slide. The online slide. It's not accessible. It's like it's not something I can share. Do you understand what I'm saying? It doesn't share anything with you guys.
Okay.
So we don't have access to it. Is that what you're saying?
So this platform I'm using is for those that have been fully registered with the DASCA platform. So it's where you can access your online resources and all of that.
Sorry, are you saying we are not registered?
If you have been registered, you're going to receive a message from the DASCA net. You're going to receive a message as DASCA. So I believe probably you have not been registered yet. That's why you don't have that access. You don't have that email. I'm going to send an email to you, obviously.
No, I don't understand though.
So there's a time I sent an email to you guys that you should.
I got back to you. I replied the email, sent everything back to you now.
Okay, I'll follow up on this as regards that. I'll follow up on this.
Okay.
Blessing will be able to say that's kind of. But is there any questions so far as what we talked about today?
Okay, mine is the same to recall. I don't have access to that online stuff.
Okay.
Get back to me.
But you have filled out Excel.
I've done that.
And you have
I also
uploaded
received
it.
an email, but I don't think I had that the file. So
You
anyway,
received
just get back to me.
an email from DASCA.
Yes.
So it means you have been registered now. If you receive an email from DASCA and you have changed
Yes,
your
I
password,
opened my platform. I've changed my code.
updated your profile and all of that.
Yes.
Okay. So I think you should have access to this platform then. I don't know why Kodawole is saying, Kodawole, are you sure you have not received any email? Check your spam folder, because check your spam folder of your email. If you have done, if Petra has been registered, Sometimes all these emails you might not really sit in your inbox, so check your spam folder for the email you dropped at the registration. Please do want to check your spam folder.
Okay.
Or your promotions. You can also check your promotions.
What
Yeah,
if the mail has been deleted because I have it set for my spam folder to be deleted?
it's at least it should be I think 30 days now.
Okay.
It's up to 30 days. Maybe have you been registered? And maybe said you have been registered too. So probably you should also have been registered. Check your spam folder or your junk folder. How about Trudy and Ayola? Hello, I didn't get that. Ayola, what did you say? Sorry, I can't hear you. It seems like you're talking. So Petra, if you have been registered, you have access to data science school now, maybe. So if you have been registered, you can just go to data science school Petra and log in with the same details that you used to log on to your DASCA Next platform. So data science school is SKOOL. Data science school. Ayola, can you talk now? I can't hear you. Can you type what you're saying in the comment section? Because how about Trudy? Trudy, have you been registered? Hello, Trudy. Can you hear me?